In this video, we're going to talk about three very important terms for hypothesis testing: type 1 error, type 2 error, and statistical power. First, I'm going to give you some simple definitions for these terms. A type 1 error occurs when you reject the null hypothesis incorrectly, or you reject the null and you're wrong. Again, error is in the title of the term, so you have to know that what you're doing is wrong. Type 2 error is when you don't reject the null and you're wrong. Again, error is in the title, so you should know that you're doing something wrong when a type 2 error happens. The last term, statistical power, is when you reject the null and you're correct. Again, most people think of power as a good thing. People want to have power. They want to make the correct decision. They want to have power. So statistical power you should think of as a good thing. It's when you reject the null and you're correct. Now let's show you how these terms relate to each other. Okay, I've drawn a distribution of sample means here. The mean of this distribution of sample means is 50, and the standard error of the mean of this distribution of sample means is 5. And that's why the steps up and down from 50 move in increments of 5. Now, in this situation, the null hypothesis is true. So this is the distribution that you expect to get if the null hypothesis is true. In this situation, if I took a sample of, it doesn't matter the sample size at this point because we're just coming up with a theoretical example, I expect to get samples close to 50, right on this 50. But it's possible that I might get things, in fact, likely that I might get things on, around the mean. All right, I'm not always going to get something right on the mean, but I'm going to get things around the mean. Right? It's possible that I can get things way out here in the tail too, but again, things way out here in the tail are unlikely. It's over here too. Things way out here on the tail are unlikely. Now I also have to draw another possibility. Another possibility is that the research hypothesis is true. When you say that the research hypothesis is true, it's another way of saying that the null hypothesis is not true. In this situation, the mean of this distribution is 60, right? That's why the peak is over 60. What's going on here is we started the test with the score of people being 50, but then the treatment changed people's scores. That it moved the center of the distribution from 50 to 60 because the treatment actually increased people's scores. In this situation, you expect to get scores close to 60, right? But you're not going to get 60 exactly because of sampling error. So sometimes you'll get things down here in the tail or up here in this tail. But most commonly, you're going to get things close to 60. Now, how does this pan out in the hypothesis testing procedure? Well, always in the null hypothesis testing procedure, you're testing the null hypothesis. So it's this top curve that you're going to be dealing with all the time when you're testing a null hypothesis. Okay, this is where you test. You decide whether or not the null is true. If you conclude that the null is false, then you assume that the research hypothesis has to be true. So you're really trying to decide which of these two curves is more likely to be the accurate situation. Which of these two curves is more likely? The thing is, you're only going to have one data point in order to make that conclusion. All right, so the next thing is to draw in our critical region. Again, the critical region is really in the top null curve. So we have to find the critical region, and you do that by using Appendix A in the back, Using an alpha value of 0.05, you're going to find that the critical region is defined by the critical value of 1.65. This area up here on the top curve, this area to the right of that value is called the critical region. If we get a value in that region, we're going to reject the null. Again, this goes back to hypothesis testing. We're going to conclude that if we get something in that region, it's very unlikely to have occurred due to chance. So this area is called, if you get something in that area, you're going to make an error. You're going to reject the null and you're going to be wrong. That's called a type 1 error. Again, let's go back and do an example. If I get a good sample, and this is the right distribution, I should get things close to 50. But sometimes I just, due to dumb luck, I get a bad sample, and maybe I get something out here. I get a sample mean of, say, 61. I get something way out here. So I, as a researcher, am going to say, oh, I got something way out here. That's very unlikely to have occurred due to chance. So I'm going to say that the null is not true. I'm going to reject the null. And if I got this answer out here just due to dumb luck, that's going to be called a type 1 error. And that's going to happen 5% of the time when I have an alpha value equal to 0.05. So 5% of the time when the alpha value is 0.05, you will make a type 1 error. If you ran the same study 100 times and the null were perfectly true every single time, 5 of those 100 times you would incorrectly reject the null. You would make a type 1 error. Now let's deal with the situation when the research hypothesis is true. In this situation, I've given a treatment to people, to my sample, and it worked. And in fact, it bumped people's scores up to 60. Now, as a researcher, I'm not going to know that a treatment worked. If I knew it, then I wouldn't have to do the research. But in this situation, just assume that we know that actually what happened is it bumped people's scores up by 10 points. So in that situation, we expect to get a sample mean of 60. But we might not get 60 exactly. We might get something below 60. We might get something above 60. We don't know. But if we get something like, say, a 61 right there, we're in this region. We're to the right of the critical value, so we're going to reject the null. And in that case, we're making the correct decision. And so the area under this curve is equal to statistical power. That area is known as statistical power. You would like that area to be as large as possible. Because, again, statistical power, you are saying that the null hypothesis is false, and you are correct. And that's exactly what you want to do. You want to make the correct decision. And there are, in today's activity, you're going to learn about the various ways that you can make this statistical power area bigger and bigger and bigger. The type 1 area always stays the same. It's always 5% of this top curve. It's always set by alpha. If you were to change alpha, you would change the type 1 error rate. But as long as alpha is set at 0.05, the type 1 error rate is always equal to 5%. Now, as I said before, you expect to get values close to 60 if you have if you did a bunch of samples. But sometimes you get something that's farther away. In this case, if we were to get something like a 55, we are not going to reject the null. we are going to conclude that the null hypothesis is true, that there's not enough evidence to reject the null. But in this situation, because I'm telling you that the research hypothesis is true, we're going to be making a mistake. We're going to incorrectly conclude that we should not reject the null. And that's an error, and that's a type 2 error. Again, a type 2 error is when you do not reject the null and you are wrong. So these are the 3 terms that you need to understand for today's activity. And as I said, there's several things that will change the size of these respective areas. But there are some important things that you need to know about how these terms relate to each other. First, a type 1 error is the only type of error you can make if the null hypothesis is true. If the null hypothesis is true, you're working with this top curve. And the only error that's possible if you're working with that top curve, if the null hypothesis is true, is a type 1 error. However, if the research hypothesis is true, you're working with this bottom curve, and there's there's one error, there's 2 possible outcomes, right? 2 possible labeled outcomes. The type 2 error is when you do not reject the null and you're wrong. Statistical power is what you want, right? Okay. There's one other way we can look at these things. And we can make a 2x2 table. And that's what I'm going to do right here. Whenever you're doing a research study, there's 2 possibilities. Either your null hypothesis is true or your research hypothesis is true. If your research hypothesis is true, that's another way of saying that the null is false. So if I say the research hypothesis is true, that's just like saying that the null is false. These are synonyms, these 2 terms. Okay? So again, there's possibility, one of these 2 possibilities is always true. The null hypothesis is true or the research hypothesis is true. And then you have possible decisions that you might make. You might reject the null and you might decide not to reject the null. This is the 2x2 table, and this 2x2 table lays out the 4 possible outcomes whenever you do a research study. The first cell right here is what's the term that fits in that cell? If the null is actually true, but you reject the null, what term goes in there? That would be a type 1 error. Another possibility is that the research hypothesis is true and you reject the null. The research hypothesis is true and you reject the null. So what possibility, what's the label that goes in this cell? That would be statistical power. And then let's say that the research hypothesis is true again. The research hypothesis is true, and you do not reject the null. So that means we're dealing with this cell, and that would be a type 2 error. Now, of course, there's this 4th outcome up here. The null hypothesis is true, and you do not reject the null. So there's not enough evidence to reject the null. The null hypothesis is true. This cell doesn't really have a name, but it might be described as correctly not rejecting. Correctly not rejecting the null. Again, you're going to want to use these terms today, and you're going to want to figure out where to use them and how they relate to each other. And most importantly, you're going to be learning different situations, different factors that change the probabilities of these different terms.